we're going to do polynomials. So the common core fact is called arithmetic. And we're going to apply doing arithmetic procedures with polynomials, right? So it says identify zeros of polynomials when factoring is available. So yeah, there's lots of ways to do to find zeros. But the way we want to do it is with factoring, okay? And again, I want to reiterate that when the quiz comes on Friday, you're going to need to do it by factoring as well as possibly by graphing as well as by using the calculator, the poly button. So let's take a look at example 1. So in example 1, first of all, before I even start, there must be 3 answers. I know for sure we're going to have 3 answers, okay? And, because it's an x cubed, and we can take imaginary answers today because yesterday we talked about imaginary numbers. So if we're going to find all the zeros of an x cubed minus 3x squared plus an x minus 3, what we need to do first is group it. If I see 4 terms and it's a cube, I do it by grouping. So let's group it. Now the first group, I've got an x cubed minus 3x squared. They have in common an x squared in common. They both have at least an x squared in common. So I'm going to common factor out the x squared. So if I common factor out of the x squared out of the first 2 terms, if I compare it, if I take out an x squared, I have 1 x left, so I'd have an x minus, if I take out the x squared, I have just a 3. Okay, now interesting, that's exactly what I have here. So what do I take out? Well, there's only really, the only thing they have in common is a 1, so let's take out a 1. Even though you don't see a 1, we need to take out something, so let's take out a 1. That's all they have in common. But that's okay because we are left with the x minus 3, which is kind of what I was hoping to, okay? Now since we're finding the zeros, let's make sure we set it equal to 0. All right. Now, the first factorization was to group it, and I see they both have an x minus 3 in common. So let's do our second factorization. So they both have a parentheses x minus 3 in common. So if I factor out the x minus 3 out of both of them, pull it out, then what's left over is my x squared plus 1 equals 0. All right, now we need 3 answers, x squared. We need 3 answers, so let's set them both equal to 0. This will not factor. So x minus 3 equals 0 and x squared plus 1 equals 0, all right? If I solve this is easy. X equals 3. That is one of the zeros. Here, minus 1, well, x squared equals negative 1. I know that I'm going to need 2 answers because of the x squared. I don't want to take the square root of an answer. I'm going to have a plus or minus, so I'm going to take the square root, and I'm going to get x equals plus or minus. Remember, there's 2 answers, a positive and a negative answer of the square root of negative 1. Now, we learned yesterday that the square root of negative 1 is equal to I. So our other 2 answers are going to be x equals plus or minus I. All right? Square root of negative 1 is I. So my 3 answers are 3 plus I and negative I. Okay? Got all 3. Okay, example 2. It says double root. So let's find out why this is a double root. Okay, so before I start anything, I'm going to take a look at this. X to the 5th, x cubed, and an x, all right? So what do they have in common? Well, I think they have a 3 in common. And I think they also have an x in common. So I can common factor out a 3 and an x. So if I take out a 3, there's basically just a 1 left. But if I take out an x out of x5, I have an x4 in common. Take a 3 out of 24, 3 goes in 24, 8 times. Take out an x out of the x cubed, I have an x squared. Take a 3 out of the 48, it's 16. All right, well, that might factor again. I know the multiples of 16 are 4 and 4, and that would add up to an 8. But instead of x and x, I think I'm going to have to go x squared and x squared. So let's go ahead. So let's keep the 3x there. And I'm going to factor this like would normally. Okay, a little side work. If I had an x squared plus an 8x plus a 16, I'd factor that into x plus 4, okay? Multiples of 16 that add up to 8, 4 and 4. Easy. The difference is this one has an x to the 4th. So we'll go x squared, because that will make the x to the 4th. Multiples of 16 have to be a plus 4 and a plus 4. Okay, now let's check this out. So now if I look at this, if I do my double summation, there's a 4x squared, another 4x squared, and a 4x squared should make an 8x squared, okay? All right, I'm not done because if I want to find the roots, zeros, same thing, okay? Set it equal to 0, okay? So I'm going to solve. I have 0 equals 3x. I'm going to have 0 equals x squared plus 4. And I'm going to have 0 equals x squared plus 4. Okay, now, I know I have to have, you ready? I need 5 answers. I really do. I need 5. There are going to be 5 roots. Some of them might be the same. That's okay. I just need 5. So the first one, divide by 3, divide by 3. 0 divided by 3 is 0. So one of my roots is 0. Second one, let's go minus 4. Minus 4 equals x squared. 2 answers, plus or minus. Plus or minus, so take the square root, I'm going to have plus or minus the square root of negative 4 equals x. Well, that is going to be 2i. I'm going to get an i from the negative, because it's negative 1 times 4. In fact, I can show that if you want. It's plus or minus the square root of 4 times negative 1. We know that's 2, so we get plus or minus 2, and that's going to be an I, okay? Now, obviously, on this one, we should get the exact same answer. Same equation, so we would do the same thing. Minus 4, square root, plus or minus 2 answers, and we get the same thing. We get plus or minus 2i. So, even though they're the same answer, they need to occur again, because we absolutely need 5 answers. So we have 0, plus or minus 2i, and then again we have plus or minus 2i, okay? So it's just a double root. We talked about the fact we have a double root. In fact, we have a double root. We have a double root. Ooh. We've got a 2i, a 2i, and a negative 2i, and a negative 2i. Okay? I'm going to turn the page. Ready? Here we go. Okay, now, what we want to do is find an equation. So there's a couple ways to do this, but I want to show you a trick. Okay, so if it has a 0 of 1/2 and 3 plus I, so before we do a whole lot with this, I do know that to get the 1/2, that could have come, and I'll put this up above, this could have come from x minus 1/2. So if I set that equal to 0, then we'd get 1/2, right? So x minus 1. So we want to put this back into a factored form, okay? So a better way to write that would be really a 2x minus 1, okay? They would both give you the same answer, but that looks better because it's got what we call integral answer. So that's an integer and that's an integer, okay? So I like that one better. So that takes care of my 1/2. So part of my answer is going to be a 2x minus 1, okay? That takes care of the 1/2. What about this 3 plus I? Well, imaginary numbers come in pairs. Hopefully you read that. So they come in pairs, so I know I've got a 3 plus I, and I have a 3 minus I, okay? Imaginary roots come in pairs, plus or minus. 3 plus I, 3 minus I, always. Always, 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 imaginary numbers come in pairs. If I flip the page, what do you know? They came in pairs. 2i, negative 2i, right? I and negative I, they always come in pairs. So, I got from a 3 plus I, I've got 3i and a 3 minus I. Now, how do I get the x squared that came out from this, right? So I've got this little form, okay? And the little form is a really handy little form. This is not in the book, but it is a formula that works really well, okay? Call this the Mr. Davies formula, okay? Whatever you want. So it says x squared minus the sum, x plus the product. Now the sum means the sum of the roots. So it means the sum of these. So that means to add. So I'm going to add these two to get this number here. Product means the product of the roots. Okay, product means to multiply. So I'm going to multiply these two roots to get this number. So what I'll create is some quadratic that when I'm done, if I did the quadratic formula, it would give me these two answers. So let's see how it works. So first of all, let's talk about the sum. So I'll do a little side work down here. The sum. So the sum means the sum of the roots. And I have a 3 plus I and I have 3 minus I. Okay, I have to take the sum of the complex roots. Right? So I have to take both of them. So the sum is easy. 3 plus 3 is 6. Right? I and minus I is nothing. So I know this 6 has to go right there. So I'm going to have an x squared minus a 6x. Okay? Plus the product. Now to get the product, I'm going to multiply them. Okay? So if I multiply my 3 plus I and my 3 minus I. And now I'm just going to go ahead and multiply. I have to FOIL. 3 times 3 is 9. 3 times a negative I is a negative 3I. I times 3 is a positive 3I. I times a negative I is a negative I squared. Okay, so far so good. Let's a little side note. Side note. We know from yesterday I squared is equal to negative 1, right? So we're going to make that a negative 1. So let's go through this. These two technically cancel. I've got a negative 3I and a plus 3. I can like that. So let's see. I'm going to have a 9 minus a negative 1, because I squared is negative 1, which is 9 plus 1, which is 10. Okay, now let's go back to what we're trying to figure out. So what we're trying to figure out is what factored polynomial will make these roots. Okay, I got the 2x minus 1 will make the 1/2. Now, how do we get these two? X squared minus the sum, that's the 6, plus the product, which is 10. If we make that equal to 0, you have a polynomial that if you were to solve it, you would end up with a 1/2, a 3 plus I, and a 3 minus I. Okay? Alright, so homework for today. Here it is. I'd like you to do page 293, 9, 11, 18, 34, 38, 42, and 42. Make sure you use the period wisely. Write the question, show all the work, okay? And luckily today you have a math teacher to help you out. So that's all I got. Bye.